All right, guys, in this example, we're going to execute and draw two parabolas, a couple of parabolas, and what we need to do is find out what are the differences between each parabola. Are they wider, narrower, taller, thinner, lower? How are they located up here on the graph displayed over here that we're about to draw? Well, I've already taken the liberty of putting up a table of values for each one. Now, the first quadratic relationship is y equals 4x squared. Now that's going to be a parabola because it's the power of 2. And the second quadratic expression is y equals x squared plus 6. We're going to put it in this table of values. Now the domains are a little bit different. The domain for the top one is from -2 all the way to 2. That means all the x values for plotting on the graph. And the second one is from -3 all the way to +3 on the x values. So let's start slotting and substituting and finding the points and then plotting them up here and seeing the difference between the two parabolas. So the first one up the top, we're looking at an x value of -2. So what's that going to be? Let's use the blue pen. So -2 squared right over here. -2 squared is 4 positive times 4 is 16. Okay, the next one is -1. Let's put it in there. -1 squared is +1 times 4 is... Next one is -1/2. -1/2 squared is 1/4 times the 4 gives us 1. And of course, we take 0 there. 0 is going to leave us with 0. -1/2, actually that's +1/2 up here. Let me fix that up. +1/2, what's a half squared? That's going to be 1/4. 1/4 times 4 is again 1. 1 squared times 4 is 4. And finally 2 squared right over here times 4 is 16. Okay, that's our points for the y along there. Let's go down and get the points for the second table of values from -3 all the way to +3. So the equation this time is x squared plus 6, as I mentioned earlier. We're going to be adding 6 to every time we square it. So let's have a look at this relationship here. So first of all, what we have is -3. Let's square that. -3 squared is +9 plus 6 is 15. Okay, the next one is -2. -2 squared is 4 plus 6 is 10. Then we have -1. -1 squared is +1 plus 6 is 7. And of course, 0 here. 0 squared is 0 plus we add a 6. So it goes up by 6. Now 1, we put 1 there. 1 squared is 1 plus 6 is 7. And of course, 2 squared is 4 plus 6 is 10. And finally, 3 squared is 9 plus 6 is 15. There are our points. Let's see how they're going to look as we plot them up there. So the first thing we're going to do is plot this one up here, the blue one, right over here, y equals 4x squared. So the first point we're looking for is -2 and 16. So -2 and 16, let me mark that up in blue. -2 and 16. Let's have a look here. -2 going up all the way to 16. That's going to give us a point right about there. So let me mark that out. There's that point. Then we have over here -1 and +4. -1 and +4 will give us a point right over here. Next one is going to be -1/2 and 1. -1/2 and up by 1, that'll be right over here. Then, of course, we're going to have 0, 0. That's going to be here at the origin, the vertex of the parabola. Then we have a half and +1. 1/2 across here and up 1, right about there. The next point will be 1 and 4. Let's go 1 and up 4. And finally 2 and 16. 2 and 16 all the way up over there. So there's our points for the blue here. Y equals 4x squared. That's the quadratic expression or relationship. It's going to be shaped like a parabola. So if I was to join the dots, let's join them up together. Yes, in fact, it is a parabola. There we go. So what I'm going to do is make it more accurate, and I'm going to put in a more solid one to give you a better view. So here we go. Let's put that in there. There's our parabola, nice and solid for you to see with good contrast. The next one down below here is y equals x squared plus 6. We've got the points, so let's start substituting them in. The first point is going to be -3, positive 15. Let's find that. -3 across here, positive 15 will be all the way up over here. There we go. The next one is -2 and 10. Let's go -2 and 10 right over here. Then we have -1 and 7. -1 and 7 right over here. It's cutting right over there. And of course we have 0, 6, which is going to be on the y-axis, 0, 6 right over there. The next one's going to be 1 and 7. Let's go 1 and 7 right over here. And the one after that is 2 and 10. 2 and 10 right over here, right next to it. And finally 3 and 15. Let's go to 3. Here we are, go up 15, that would be about here. So 15 is about over there. So now all we have to do is join those dots. Now this parabola is doing something interesting. It looks a lot wider. Looks a lot wider. It's got this kind of a shape. So let me make it more solid so we can see it and then determine the differences between the two parabolas. Okay, there's our second parabola. So as we look at them visually, what are the differences? Well, for the first one, 4x squared with that 4 coefficient means that we have a narrower parabola. And because there's no plus on the end, it goes through the what? Through the origin right here at 0, 0 on these axes where they intersect. Now the second one here, y equals x squared plus 6, is simply the parabola y equals x squared, and it goes up plus 6 on the y-axis. So it just goes up to 6. You can't see it there, but the 6 is there between the 8 and the 4, right there. Goes up there, and it's just a regular y equals x squared parabola. So we can see that one also is wider because we don't have a coefficient up here, because the bigger the coefficient, the narrower. So we got a narrow one here and a wider one over here. So that's our two parabolas, and the difference between them is that this one is wider and this one here is narrower. The blue one over here is 4x squared. So that's how you draw them.